Assalamualaikum and good morning. Today I would like to present my portfolio. The title is Seismic Interpretation and GeoHazard Assessment of Subsurface Structures in Malay Basin Offshore Terengganu. I would like to present my name. My name is Asdam bin Muhammad Zamri. My matrix number is E24B3366. And my program and institution is Bachelor of Applied Science Geoscience with Honours, Faculty of Earth Science, University Malaysia, Kelantan. I would like to start with introductions. My background of study is hub of energy. The Malay Basin, specifically the offshore Terengganu sectors, serve as a primary hub for hydrocarbon production in Southeast Asia. Next is geophysical lens. This study utilizes non-invasive 2D and 3D seismic reflection technology to image crustal geometries thousands of meters beneath the seabed. Next is modern integration. Subsurface is integrated with Geographic Information System (GIS) and work with remote sensing to create a multi-dimensional model for risk assessment. And for the problem statement for my proposal and my portfolio is the height uncertainty. This mature sedimentary province features dense fault systems and stratigraphic inconsistencies that introduce high level of uncertainty in reservoir predictions. Next is exploration risk. Conventional methods often fail to resolve hidden structural traps, leading to unsuccessful drilling operations and financial setbacks. And lastly, for the problem statement is knowledge gap. Without high resolution structural modeling and sophisticated seismic analysis defining reservoir continuity and fluid migration, pathway remain challenging. And for the methodology, step 1 is data acquisition and preparation. It is to identify target seismic blocks located approximately 150 kilometers to 250 kilometers offshore Terengganu. This is to collect secondary 2D and 2D or 3D seismic SEGY files and geophysical well logs from Malay Basin's archive. Step 2 is seismic data preprocessing to import raw seismic dataset into interpretation workstation such as Petrel or OpenDetect, and to apply digital filtering and noise reduction techniques to enhance subsurface reflector signal quality. Step 3 is horizon picking and fault delineation. To perform horizon picking to trace continuous Miocene sedimentary layers across seismic profile and to identify structural discontinuities, faults acting as hydrocarbon traps and migration pathway. Step 4 is to to detect the time to go through depth conversions. Converts two-way travel time into depth using velocity models. Also improve accuracy of structural interpretation and reservoir mapping. For step 5, GIS integration and spatial mapping. Export interpreted horizon and fault polygons into RGs. Conduct spatial analysis to integrate geological and geophysical datasets. And for the last step is final outcomes and reporting. Produce a high-resolution 3D subsurface structural model, compile reservoir potential and structural integrity assessment report. And for my research objective, next part is for my research objective to identify prospective hydrocarbon containment zones and reservoir segment within the offshore Terengganu Basin through analysis of 2D and 3D seismic reflection profile to characterize primary faults and stratigraphic horizons influencing the hydrocarbon migration and accumulation in Malay Basin. To evaluate the physical characteristic and lateral connectivity of reservoir strata, we are using seismic attribute analysis to reduce exploratory risks. For the tool in this project is ARGIS, GIS Analysis Map Reproduction Digital Elevation Model, DMS. Next is Seismic Interpretation Software, processing SVG file and automated fault detection. For the technical limitation, study relies on secondary dataset from 2014 till 2024, where older seismic lines may contain signal noise. Since the project is computer-based and offshore, field accessibility is unnecessary. For the literature review, seismic interpretation in resource exploration. Seismic reflections techniques are the industry standard for offshore subsurface imaging, allowing the high resolution visualization of geological structures such as faults, horizons, and stratigraphic traps. Modern 3D seismic dataset improve reservoir estimation and structural interpretation. For geological controls on reservoir distribution, the reservoir distribution in the Malay Basin is strongly influenced by lithological compositions, stratigraphic sequence, and structural fault system. Fault-governed migration pathway play a major role in hydrocarbon accumulation. Next is fault mapping and trap identification. High-resolution seismic datasets allow a detailed mapping of fault systems that act as hydrocarbon conduits or barriers. Structural compartmentalizations reduce uncertainty in reservoir evaluation and exploration. Okay, this is my research flowchart. There is step 1, data acquisition and preparation until the final outcome and reporting. The reference is shown, and for the significant outcomes, there's 3 points. Industry support. Supports government agency and petroleum stakeholder in identifying high potential exploration targets while improving drilling success rates and reducing capital loss. GEOHAZARD mitigation provides framework for identifying shallow gas geohazards to protect offshore infrastructures and petroleum assets. And for the economic and economic value, establish a structural framework contributing to regional economic growth and academic research at University Malaysia Kelantan. Okay. The study area and geological setting. Geographical location. The study focused on northern and central Malay Basins province, approximately 150 to 250 kilometers offshore from Terengganu coastline. The geological setting. The basin is sedimentary, represented in the South China Sea with thick Miocene strata and northwest southeast oriented anticlinal faults. Climate conditions. The northeast monsoon significantly affects offshore surface condition and structural integrity. And for the conclusion, this study demonstrates the effectiveness of integrating 2D and 3D seismic interpretation with GIS-based spatial analysis for subsurface characterization in Malay Basin offshore Terengganu. The approach enables improved identification of fault system, stratigraphic horizon, and potential hydrocarbon reservoir, which are critical for reducing exploration uncertainty. The findings highlight that the Malay Basin is a structural complex region where fault control, traps, and Miocene sedimentary structure significantly influence hydrocarbon distribution through systematic seismic interpretation. The study enhanced the understanding of subsurface geometry and improved prediction of reservoir continuity. In addition, the integration of modern geophysical tools and remote sensing techniques provides a reliable framework for geohazards assessment, particularly in identifying shallow gas risks that may threaten offshore infrastructures. Overall, this research contributes to more efficient and safer hydrocarbon exploration by supporting better decision making,
reducing drilling risks, and strengthening the geological understanding of the Malay Basin. Thank you. This is all for me today.